Hi class, let's take a look at problem 11. It's a bit of a short problem and this is what we're given. So we're given a relation which is pretty much just a set of coordinate points. The information that it's not given is how they obtain the coordinate points. So in any case, we just have the coordinate points. And then one of the questions that it's asking is f defined as a function? Now, remember that for f to be defined as a function, you have to satisfy the following condition. You cannot have, in terms of the coordinate points, two coordinate points that happen to have the same x and a different y output. So technically, we would draw a vertical line passing through all of these to make sure that you couldn't have one x value giving you two y values. So in this case, you would simply draw some vertical line in there and then state that yes, the relation passes the vertical line test, which means that you don't have a condition where the value of x is equal to 3 will give you two y values. So in this case, this relation, yes, it's defined as a function. And then we simply draw a vertical line and then state the fact that it passes the vertical line test. So that's actually it for the first part. Now, the second part is asking if f is defined as a one-to-one function. Now, when we refer to a one-to-one function, it's pretty much the same idea of a vertical line test, but it has to deal with the inverse. And if you were to do the inverse for the second question, now you're looking at all the coordinate points flipped. So in this situation for part B, for the function to be defined as a one-to-one function, you cannot have two y values to be the same. So in this case, we would draw a horizontal line and check that you don't have two y values that are the same. So you couldn't have a 10 here and another 10 out here, or a 7 and another 7. And then we simply verified that in this case, we do have two coordinate points that happen to be the same. In this case, 8, 4, and 3, 4. And then we can see that, well, here, this one happens to fail. So we only have that the relation is a function. It is not a one-to-one function. We do have to mention the horizontal line test. So in our final sentence, we will state something along the lines. And let me just make this so that it's visible to the above. So the relation does not pass the horizontal line test. So we just have that this relation is a function, but it is not a one-to-one function. Here it fails because you have two outputs that happen to be identical y values, so 4 and 4. In this case, I'm just gonna leave it there. Unfortunately, this relation, it's not providing us how they obtain the coordinate points, and we're just checking to see if it satisfies to be a function. In this case, yes, it is a function, but it is not a one-to-one function because of the identical y values. That's actually it.